Okay, so Gabby basically asked about this, a child sliding down on a snow-covered hill.
Let me try and find that one, yeah.
Gabby, what year is this? Oh, I think that's a school paper, is it?
Yeah, that's school paper from last year. I think Maris or something.
Okay. So it says state the energy transfer that is taking place as the child and sledge decelerate. Now it's important to take note that there will, I think this goes for everyone. When you decelerate, right, there will be no transformation to KE, no conversion to KE. That's the important part. Alright. That's the text. No conversion to KE or kinetic store. Why is that so? The whole idea of deceleration, uh, deceleration would mean that your speed, the speed decreases. So if your speed decreases, your KE should decrease, what? Do you get the logic? So you cannot say that the gravitational potential energy is converted to KE. Because if it converts to KE, right, then you shouldn't be decelerating, you should be accelerating. Because with more KE means more speed. So that'll be wrong lah. You gotta take note. You can say the KE that was converted from GP at first is converting to internal store. Also can. Yeah. And any further drop, any further decrease in or any further change of gravitational potential energy will be converted to internal store. It cannot go to KE lah. So that's the tricky part to this question. Now sometimes there may be a question that asks you about object falling at terminal velocity. I did see this question before. It's actually a pure paper. So they asked about the energy conversion. And they got option A, which is the common one like GPE to KE. Why you keep slamming cups, man? The cup did nothing to you, Samuel. And then they have like GPE to uh heat lah. They make it very obscure. Then they have others like KE to heat, for example. Which one do you think is the answer of these three? A, B, or C?
Only answer is the child.
Gary, what do you think is the answer? Whoa. Oh, my text cannot get back. Huh? This is my question to you guys.
I think it's B. Yes, it is.
It's B lah, but a lot of people chose A. Because object falling ma.
That's true.
In your head, you keep thinking falling means
Can I take one?
yeah,
Actually,
always
why is it?
because terminal velocity. There will
Means there is no more KE.
there's no increase in KE. Your GP that you fall, let's say for every 1 second you lose 10 joules of the GPE. 10 joules goes to your KE ma. So your KE must increase as your speed must increase as a result. If you're falling at terminal velocity, there's no way for you to increase in speed. Therefore, all the GP converted will then go to heat. Or as nowadays they call it internal store.
Internal
Internal store is another name for heat.
store seems like heat block friction, not others.
Yeah, work done against friction. Okay?
If I want to include friction, I must specifically say work done against friction, right?
Yeah.
Okay.
Work done against friction.
Okay, so I saw there's like confirm this part is wrong because it's
Uh-huh.
falling. This is if feather hits terminal velocity. This was what I assume, which is that the feather just hits the ground at one point. So like
Uh-huh.
I was like what is
Um,
the
the speed. The issue is that the speed is decreasing. Drop the gradient is gentler, which indicates the speed is decreasing. So you know this is correct, right? Which means that the speed kept increasing, right? So if you draw the distance time graph for this, you have drawn something like that, like curving up,
oh,
which is not this one.
accelerating due to fall.
Yeah, this is decelerating, which could mean like the feather had a parachute, for example.
Okay.
Yeah.
Oh,
Okay.
You are drawing the 10%. So like,
maybe it's like C or D. I have never seen this part of the question before.
Newton's third law. If it's to the right, it must be to the left on the other side. It cannot be to the right to the right. Because this is on the wheel, this is on the road. So equal and opposite, ma. The keyword is opposite.
Oh,
If it's to the right on the wheel, then it'll be to the left on the road.
okay.
Yeah. Okay.
We should have. So I knew the answer was D, but what's the reasoning for D?
Work done is
Toss in the direction.
this one is lifted, right? So this is work done against gravity. So gravity is downwards.
Yeah.
So it's force times distance, and the distance is just between A and B. It's a straight line. It's perpendicular distance.
Okay.
So regardless of which direction, it wouldn't matter because the force is downwards. The force is downwards at all times, which means that you should only take the distance that is downwards. So whether you go here, you also take this component, this distance.
Okay.
You go by P, you take this distance. You go by Q, you take this distance. You go by R up like that, you also take this distance.
Okay.
Yeah. They call it conservation conservative force. Gravity is a conservative force, which means that whatever distance however path you take, it will be the same
Yeah.
because it's down all the time.
Do you know that?
No, it's a JC thing.
What?
What's this you ask? Why that way? Draw two cells to complete. What mean why that way? What's your question?
The current, I thought they go from long to short. Why they go from short to long? Or rather from left, like like the cell,
I
right?
think it doesn't matter. Either way is fine, so long you draw
Long and the short.
the batteries in the same direction.
Oh, okay. Because originally I do it the other way.
No, I think that's fine.
So either way can.
Yeah.
But what about if it's one of those stupidly easy papers where they go down to the nitty gritty where you were spelling mistake or forget to cross your T and dot your I, cause you the mark kind.
There will be something to tell you that is the other direction, which there isn't here.
Which means it's free game.
Yeah, either way is fine.
Okay. Then the next day.
Wait, hold up. I'm sensing something. Oh, okay, I get it. You can't do the other way because of the diode. There's a diode there.
Meaning
Diode is one direction only.
unidirectional, monodirectional.
So you must put it this way so that the current can flow.
So it's the positive just to come from the right side then.
Yeah.
Okay.
Let's see, this is the diode. So the current comes out like that.
Yeah.
It must flow like that.
Uh-huh.
Okay? If the current comes out the other way like that, right?
Yeah.
The diode will block the current.
Okay.
So the circuit will not work.
So a diode is not like a regular filament lamp where any direction goes.
It's if you see the symbol itself, the whole idea of a diode is one direction.
I see.
It's a Google Play Next button, YouTube Play Next button. So over here, you can see this one looks like an arrow, ma. So follow the arrow. If the current follows the arrow, then the current can flow through. Whereas the other one
Yep.
is a wall. It's like a wall. So imagine you're hitting a wall.
Uh-huh.
So current not flow lah.
Mm-hmm.
As what Gandalf would say in the first Lord of the Rings movie, you shall not pass. Yeah.
So there are some college
How
professors
do you even get a reference?
like dressed up as Gandalf.
You weren't even born when the movie was made. 2007, I think. How do you know?
2008.
You were 1 year old. No. The movie was 1 year old when you were born.
I'm in December 2008. I'm still that big.
There was a college professor that dressed up as Gandalf,
Oh,
and then he stood in front of the students as they made their way in to take the exam. And then he said, "You shall not pass."
I saw a different video on actually. There's also a college professor in the US. It's like if your name is called, please stand. And then he was in a Gandalf gambit. It's like dumped this thing on the ground. It's like you shall not pass. And then he said to the rest of the class, you gotta see her and then have a nice holiday.
You got to see or have a nice holiday.
See or better.
Oh,
Implying that they did pass.
I see.
I've seen that before.
Yeah.
So I know how to do standard mirror questions like this,
Mm-hmm.
but how do I like transpose these guys onto there? 'Cause I thought it's like this.
Which man can be? Oh, there's a mirror there.
Yeah.
Oh, this is a good question. Can you take a picture? Send to the chat group. What's the question for this semi-long?
Hold on, let me flip the thing.
Wrong circle formula.
Yeah. I haven't done that in a while, as you can tell.
You need to include the 4 times 10 about 2 kilometers over there.
Whoa.
You can't just include 6.4 times 10 about 3 kilometers. You need to include the additional radius. Because that's the radius of the Earth. What you're having now is radius of Earth. We need to get radius of
gee, yeah, I forgot to plus the 4 times 10 power to
Yeah.
which is ground to satellite.
Yeah. Hey guys, do take note of this. Radius of orbit is different from radius of Earth.
Whether in general.
So radius of Earth is 6.4. They ask for radius of orbit. To find the answer for this radius of orbit, which you need to include this one here. Okay? Yeah.
Also, I use pi r squared instead of 2 pi r.
This one here.
Yeah.
Oh,
That's
why do you use pi r square?
why I use pi r squared? Because I'm an idiot.
Pi r square is what? Area of a
Yeah.
circle, not perimeter of the orbit.
I'm an idiot. I haven't done math in a while, if I can see.
Oh, this one must talk.
Oh,
I think this one you know lah. Okay, so when you're moving in a circle, this is important for everyone. And since it came out in TYS, it's something you must know lah. When you're moving in a circle, you are always constantly changing in direction. Example, you are here, the direction is here, right? So let's call this V1, and then let's call this V2. So V1 is a vector and V2 is a vector. These are velocity vectors. Are they the same?
V1 does not equal V2, right?
Let's assuming constant speed. Are they the same velocity?
I assume so.
No, they are not, because clearly they are moving in different directions. So if you take V1 and put it here, okay, who has done vectors in math?
No.
Vectors in math.
What the should have done?
yeah.
Okay, so vectors in math. So this is V1 and this is V2 lah. What's the definition of acceleration?
Change in rate of speed, right?
Rate of change of velocity.
Change of velocity.
So in this case, it will be v2 minus v1 over t. Okay, final velocity minus initial velocity. All right.
Mm.
Now, if you translate to vectors, okay, you need to switch this a bit. The v1 need to flip the direction, which will give you this minus v1. Why minus v1? It's because it's negative. So when you subtract vectors, right, you have to flip the direction. And therefore, when you do the head to tail method and you combine, you'll get delta v, which is v2 minus v1.
So what's the head to tail method?
Never mind, it's okay, you don't need to know if you don't do vectors.
Choice of NA magnitude.
But if you subtract vectors, you will get this lah. The whole idea is that if I teach students head to tail, it will be something like if you are walking from here to here and all the way to this end, the direction here must be the same as if you walk here. So that's the shortcut TLDR version of it. Anyway, moving on, the delta V would then translate to something like this. So what this means is that at any point in time as you're doing your orbits as a satellite, right, you're gonna get something like this. All the delta V's are towards the center. And as you know, A is delta V over delta T, which means that all the A's are towards center, which is why the ISS accelerates continuously. Short answer is velocity changes all the time.
Okay.
Velocity changes all the time because direction changes all the time.
Mm-hmm.
So which means that there is acceleration.
But B says acceleration is caused by a change in the velocity. That's the acceleration definition, right? And then it goes,
Rate of change of velocity. Yeah.
and then it says, since velocity is a vector quantity, then the direction of movement of the item changes as it orbits the Earth, there is acceleration.
Yeah.
Such as to say that because acceleration is the rate of change of velocity, and since velocity is a vector quantity, which means that it has magnitude and direction,
Yeah.
and the direction of the movement of the ISS changes as it orbits. So one part of the vector is always changing, means there's acceleration.
Yeah.
I think
So long as change in velocity, there's acceleration.
what? Change
So
in
long as change in velocity, there is acceleration.
So you have to explain all that for 1 month. It's just
No, my okay, this is good to understand as a background and also for H2 physics.
Do I probably
Because you're gonna be doing a lot of this if you're in H2 physics. This is the answer. As is moving in a circular orbit, the direction changes all the time. So velocity changes all the time. Therefore, there is acceleration. That's it. That's the 1 mark answer.
Okay.
That's all you need to put. This is a simple version. This is the logic behind the abstract part of things. Yeah.
When it comes up for this year's paper. This is 2023. I hope it doesn't come out. Hey.
Because when I teach, there's a range, right? Like I can teach you what you need to know on the surface. I can go deeper.
Well,
So this is the deeper part, and this is the surface part.
using diagram.
Yeah, if you regurgitate out all the thing here on the side here for 1 mark, you still can get a mark, but it'd be a waste of time.
Time and penning.
Okay, what was your wait. Let's jump to
Next one. Literally the next page. All
Yoshi got an interesting question.
the Yoshi question.
The Yoshi question. Okay. Yeah, this is the one. Wait. What's up with this thing, man?
Plain mirror X-ray Yankee is
Okay.
corner of the road.
What do you do when the mirror is slanted? That's the question,
Ah,
right?
yeah.
Now, what you can do is that you can draw, get a darker one. You can draw a invisible line, okay? And then treat this invisible line as the mirror. It's the extension of the mirror. Then the next thing you want to do is, for each of them, you do the same thing when it comes to tracing out your reflections. This is perpendicular distance. So, I'm trying to be, because I freehand this, may not be correct. Is it here? It could be all the way here, I don't know. I'm freehanding this, so do try yourself on paper lah. Then this one, right, could be here lah. You really have to take a ruler and draw it out. I can't produce the same result here. Then this one, right, you should do like here. Is it? Let me calculate. Maybe about here lah. Okay, so from here, draw a line. It has to be a straight line lah. Can I draw a straight line with this thing? Let's see. From the image, draw all the way to the observer. Okay? From the image, draw all the way to the observer. Okay, so let me use a red one this time around. So the idea is, if it hits the mirror, then
You can see the
pass lah. If you see this one doesn't hit the mirror, goes through blank, goes through air, so cannot pass. This one fail. Okay, so R is out already. Wait, answer is C. Why is R inside? Then it could be my drawing something wrong. Like I said, the distance I'm just approximating only. But based on what I see here, R didn't pass lah. And then you draw the lines, you connect to P and connect to Q. Again, if there's nothing blocking, then pass lah. Okay, so there's two criteria. Must pass through mirror. And so that's criteria one. Light from object must not be blocked. Then you can see. How come the answer says Q and R? And from here is P and Q lah.
So ruler try to keep perpendicular to the extended mirror.
Yeah.
So I roughly got Q prime here.
Mm-hmm.
Then
Oh, so
okay.
Q prime, okay.
I don't even
R will be from here to here, and then
like this.
oh, R is like somewhere here, I think.
Will it be like this?
Yeah, yeah.
How do I even know perpendicular?
If you can make a right angle, it's perpendicular. Or if you take this line, you align with it, then it's like going to be perpendicular lah. Apparently, I'm looking at Yoshi's question. The R is like somewhere with the Q as well. I don't know why, but it's very, very close. So anyway, the point being is use a ruler. Okay? I can't do it because of the limitation of the tag. But use a ruler, trace the image on the other side, draw a straight line. It must cut through the mirror. If it does not cut through the mirror, you cannot see it. And the light that comes from the object must not be blocked. Just two criteria only.
What's the chance that this is going to foul combines?
Maybe. Okay, slanted mirrors usually for pure, but you will get like a plain mirror. You will get something like this for combined science, right? A typical question will be something like this. Like maybe this is Harold. And then this is Samuel and Yoshi and Gabby. So then they ask like who can Harold see in the mirror? This is a much easier one lah. Because I think what stumped Yoshi was the mirror being slanted, right? I suppose.
The position of the people, like, I don't know how to like,
Yeah.
put them up to the other side.
Yeah. So the very, very first thing, right, is to draw an invisible guideline to tell yourself that, hey, this is going to be my mirror. Okay. I'm just going to use this invisible guideline to trace out the distance, find the images, and then draw a straight line to the observer. It's the same for this one also. Like here, right? You draw an invisible line. So Samuel will be here. Yoshi will be here. And then Gabby will be here. Then you draw a line to Harold. Okay? And then after that, if all pass through the mirror, then all pass lah. Then you can draw the lines from the object. So Samuel one will go here. Yoshi one will be here. Then Gabby's one will may get blocked because maybe lah. Let's say if I draw the wall longer enough, it'll get blocked. So this is one example where the second criteria is not fulfilled. Yeah.
I think the one smaller, I would still see Gabby as like gambling.
Not necessary because Samuel is here. Gabby is just behind but in the middle. She's behind but in the middle. So yeah. But they won't ask. I think what you're saying is they would ask like, oh, because Yoshi is here blocking Gabby's view. No lah. No.
Yeah, so it's like in the answer keys correct. It's Q and R only. It's P is right here. But the line of sight is over here.
He is right here.
P is on this top where
Uh-huh.
yeah.
You should connect what?
No, but his line of sight was out. Like the edge of the mirror is right here.
Oh, that's the line. Okay.
Yeah, just this P.
Okay. So do think of this interesting question. Yeah.
Okay. Then this question. So I thought since this line didn't have any notation and that they were here, I thought this is like the focal point. That's why I put A.
Not necessary. Yeah, you want to draw focal point, right? You want to find the focal point, right? You have to draw a line that passes through optical center that must be parallel to the two of them. Then you can see you can confirm 100% that it's focal point,
Oh.
which will be something like this. You aga. Something like that. Draw a faint one. Yeah. Which passes through lah, looks like, but that's when you confirm lah. We must confirm it with a optical center light ray that is parallel to the two of them. Yeah. RS.
Just I thought too.
Yeah, then you will go through B. This is the converging point, but this is the focal point.
I thought all light rays will have to pass through the focal point.
No.
No.
All parallel light rays. All light rays parallel to the
To the
principal axis will pass through the focal point.
okay.
If you are not parallel, you will pass through a point that if you draw a line down, it will be the focal point.
Okay.
This is the converging point.
All right.
Yeah.
Okay, anyway, on.
Samuel Long. Okay, what else we got?
I got like another 13 more pages of questions to ask.
Hey, you don't wait till like the day come then ask lah. Like you can drop in photos, pictures along the way one what.
So you take like 3 business days to respond, bro.
At least I can see first and tell you which one is the one.
So for this one, right, negative, increasing negative acceleration is curve, right?
Increasing negative acceleration is a curve. Yeah.
So which one is it? Yeah, so it go down.
So what you just drawn?
Okay. So the one that goes down the slide.
That will be decreasing negative acceleration.
Okay.
What's this? What's the question you asked?
That's correct.
Is
This is only positive. That's like half correct, half incorrect according to my answer is the heat causes the particles surrounding the particles surrounding to vibrate faster, thus increasing the internal energy of particles. The particles thus knocks into its surrounding particles, causing them to increase in thermal energy.
it says to all parts of the kitchen. Do you think this is how her heat is transferred to all parts of the kitchen? So what else can there be? What are you describing here? Thermal energy process. What types of processes are there?
These
3C? What are the 3Cs?
conduction, convection, sorry, 2 C's and above, conduction, convection, radiation.
Yeah, so what are you describing here? And why didn't you use any of the keyword like conduction, convection, radiation?
Okay, so let's do it. That's conduction,
You only describe conduction here.
but I never actually stated it.
Yeah.
So I'm supposed to state and explain.
Uh-huh, but there are also others, what? Why is convection not included here?
No convection current, no. So what? There's no convection current.
Is there no convection current?
Wait,
How do we know when there's a convection current?
how do I know when there's convection current? When there's a heat source below.
There is a heat source below. What?
Oh, so there is convection. No wonder why you see.
The floor tiles gets heated up by the wires.
Causing the air,
So the floor tiles will be hot, so it will cause the air around the floor tiles to get heated up as well.
which means they become
Then
less.
they expand, then they will rise. Yeah, they become less dense. So there is convection. There's also radiation, what?
Well, there is.
In any case, no matter what the situation is, so long as there's a heat source, there will be radiation. Unless you have things like silver color or the good reflectors of yeah. But there's nothing about that here. So you can actually talk about radiation. Yeah. It's a good 4 marks to have. And lastly, they said, what are the first 3 words of the question?
Describe the processes.
Processes. They only give you a clue. There is more than one process. Okay, moving on. What's this for? Huh?
Quickly, some like I was just looking at this voltage shifting
Highest power transferred.
as power.
You use either P with the I squared R. Yeah, I think you can use P with the I squared R. You set R as a imaginary number.
Yeah.
Then find the I squared R. Actually, yeah. Or maybe V squared R, V squared R, because same battery.
Oh.
Samuel, this one is under which one? What part is this? Because you send me like that,
Wait.
there's no front question. This one?
No.
But the next picture is this.
Not on my phone. So this one is this one.
So can you tell me which question is this?
Question 9, part B out of 2 to 3.
Samuel Long.
Oh yeah, I have about the same amount of chemistry obviously.
Then you should just send it over first.
Okay. I'll send the model fact statement.
What's this?
Okay, so do you want a question? I have my TYS here. I can send you over. For just now that question.
Oh,
Yeah.
okay. I'll just look at. I just follow whatever he sent me the order lah. Yeah. What about this one? What's your question?
What formula is this?
Oh my god, this guy.
You say what the what is he so rich? I'm only without impression.
It's like a hot dog. Okay. Can anyone help Samuel Long on
What?
what formula is this?
Is it some schools they don't teach to
Because I
Huh?
is it some schools won't teach to combine the
They should teach. They should teach.
my school doesn't know that.
Your school doesn't teach this?
Yeah, doesn't teach to combine. Because the teacher don't want to confuse them.
Huh.
Never.
Potential divider rule.
Oh,
I've taught you before, and when you guys were going for your practical, I said that if you were to prepare for one thing before the practical, it'd be you should know potential divider rule.
never came. That's not gonna be later.
Yeah, but the fact that I told you to prepare means that you should have prepared in some ways, regardless of whether the question came out or not.
Okay.
So, what happened to it? What happened to all that memory, the contents? Huh? Do you recall that?
I telling me to remember
This is potential divider rule.
potential divider rule equals both potential divider rule is both equals to R1 over R total times both.
Yeah.
Why is that wrong? But really which is so V equals R1 over R total. Variable is 15 potential of the 12 ohms. So then it should be V equals R1 12 over R total 15 12 over 15 times EMF 6.
You know what's the issue with your working?
I tried to use R equals U by.
Why is 6 over 14? What's this? 6 over 15, this one.
Yeah, 6 over 15.
Okay, when you get this, uh 6 over 15 here,
Yeah.
this is 6 over 15. But when it branches out, they're asking for the PD across the 12 ohms.
Mm-hmm.
When it branches out here, is this 6 over 15?
Probably not.
And that's where the mistake is.
Um,
So if you want to continue, what you could have done is, you should have found this one, the PD of the 7 ohms. Let's say you do have 6 over 15,
okay.
you just take 6 over 15 times 7. And what's that?
Did I
Can you calculate that out? Is somebody calculating?
equals R 7 times 6 over 15.
What is 42 over 15?
What? Sorry. What's the answer to that question? It's
2.8, right? Okay, so you got 2.8. Let's say you found the answer and it's 2.8. So to find this, what do you need to do? To find the PD across the 12 ohms. Why are you looking at the answer, bro?
we are just once.
3.6. It should be 3.6 volt. If based on your working.
Which is incorrect according to the answer key.
And either your working is wrong or
the answer key is wrong. Like,
what's this here? 1 over 24 plus 1 over 12. 15 ohms is correct. Oh, I put. Yeah, then 3.2 lah. That's correct. So you should get potential difference across the 7 ohms as 2.8 volts. Then you just take 6 minus 2.8 to get the answer. Can also.
Okay.
So you don't need potential divider rule. It's just that potential divider rule is much faster.
Okay.
It's a 2 marks question, but you did 3 steps,
Mm-hmm.
which is still okay. But you could have done it within 2 steps.
Yes, you.
Using potential divider rule. So it's a very good formula to have.
Okay.
Yeah.
Okay. So, live wire, presumably in contact with earth wire.
Uh-huh.
So that's like short circuit and all, but I thought that would have made the fuse like explode, not make the metal case become live.
Live wire in contact with.
Wire that
Oh,
we've connected here.
no, it will not cause a short circuit.
Yeah.
Only when something is connected to the neutral. Like the live uh goes to the neutral. Lah. Maybe some of the wires are exposed and they touch each other. But basically when you put like this, right, then the live comes out in two wires. Means the current is flowing 2 ways. One goes to the appliance and one goes to the metal casing. That's all. And the metal casing, if the appliance is working properly, the metal casing does not have any electrical contact with the appliance. So you wouldn't have the short circuit.
Okay.
Do you know what I'm saying? Um,
Good.
so the schematic of it, right now, okay, this is a appliance working in proper order. Okay? So I show you what is a not proper order. This is the error now. So this is gone, and this is the error now.
Wow.
So what's happening is you have current going out here that goes through the appliance, and you also have current going out here. 2 paths. So this one will go here and it will stop lah. And it will be positively charged. The whole metal casing will be positively charged. Whereas this current inside here will go past the appliance and go here lah. And it will continue to operate as per normal. But the moment somebody touches the metal casing, like Samuel's finger, for example, then he will get a nasty shock. That's all. There is no short circuit.
Alright.
Now, when there is short circuit, it will be something like this. Like,
Multi-touch neutral.
example, this happens, or maybe like this happens. So the current that goes here suddenly diverts to the metal casing and goes here. Then you get a huge current flow. Then this will cause your ELCB to blow. Earth leakage circuit breaker to blow. It will break lah. So that's an example. The second example, it will be the neutral and the live sort of touches each other. Exposed wiring. So because all of them are very close in the socket,
Yeah.
so there's a chance that exposed wiring will cause them to have electrical contact. Yeah. That will cause the fuse to blow.
Yeah, I don't need to know like definition of a short circuit, right?
You don't need to know definition of short circuit, but you should know the logic of a short circuit, which is current bypassing the usual appliance, the usual resistance, such that there's almost zero resistance and it causes a huge increase in current flow.
Okay.
And then the circuit, yes.
It's not exactly dangerous, right?
The short circuit is dangerous if not attended to in time. Because what happens is that the current will keep flowing and it generate a lot of heat. So it causes the area around the source to heat up. If there's enough heat, right, it'll start to melt. And certain electrical components may catch fire. And then
Electrical fire.
you have electrical fire. And that's what happened before the circuit breakers and the fuses were created. There were electrical fires. And because of what we have today, we don't have that anymore, or it's very little.
Oh, I tell you. Well, then why do we have all the exploding EMDs?
That's because the cells. It's the cells inside the battery. Nowadays, there's not only exploding PMDs, but there's also exploding
And
Samsung Galaxy handphones and all those things.
Like fully charged, then you like stop current from flowing.
It's not about the charging part. It's about the proximity between one cell to the next cell. In the challenge for making batteries today, right, is that you want to squeeze all the cells in a single small compartment
wow,
while making it lightweight and everything. So all the phones they always say, wow, can hold for very long and all those things because you got more demand for stuff these days, especially with ChatGPT and all that. So there's a lot of electrical energy requirements, but you need more a battery with larger capacity to store the energy.
mhm.
So what do? They squeeze all the cells together, closer to each other.
At the risk of exploding and killing somebody.
So when that happens, there's a risk that the heat accumulates too much inside. And if the component was produced like a few micrometers in error, then they may be too close to each other. And that will cause the phone to catch fire. The same for PMDs also, right? PMDs, you want to make everything lighter, you want to put you want to have like maximum amount of energy stored and so that it can go faster, it can travel a further range. So there's a chance also that it will catch fire. Yeah. And some people like to modify the circuits in the PMD to remove the speed limiters and all that. If you're not doing it correctly, then you may cause short circuit to happen, which is another problem. Yeah. What's the issue for this one? Possible red laser light. What acceptable answer?
Oh, we're there, really? Okay, well, we glossed over a lot of stuff.
Oh yeah, the possible wavelength and frequency of the laser one.
Okay, I suppose it's important for you guys to take note that visible light has a certain wavelength, which is 400 nanometer to 700 nanometer. So the smallest wavelength would then be violet. The largest wavelength would be red. So ROY GBIV. So you can remember 400 to 700 nanometer. That's one way to do so. If you need to convert to frequency, you can use C equals to F lambda to go and convert. So for red one, you should be taking the 700 nanometer. You put 600. I think possible. About the range.
About the range.
Yeah. It's
Okay.
700 actually, you're going to be safe. But 600 is just next to 700, so still acceptable.
Okay.
Yeah. But it's good to remember these values lah. Yeah. Okay.
Mm-hmm. Honestly, I just use the neighboring terms because next to one side of visible light is infrared, the other side is ultraviolet, one red, one violet.
Mm. Yeah, everything's all jumbled up. I don't even know what. I don't even know where are we now. What am I? What should I be looking at? Yo, dude.
So okay, now to jump to the next paper. Uh, Stupid computer lah, jumbo everything. Oh, there we go. This is the reference image.
Yeah. Explain what above and then moves towards the left.
My answers are half my answers.
Okay.
Right hand grip rule lah.
Uh-huh.
Use the right hand grip rule, then that should be a south on the right side. Then the bar magnet is north, right? Left side of the bar magnet is north, right? I
Mhm.
just saw it briefly.
Wait, so using right hand grip rule, the thumb points towards the south or
North.
to the
The
north?
thumb is to the north.
Wait, using right hand grip rule, long to the short, so that we, oh, right. So it's going that way.
Do you even send me the question?
I did. Well, not no. Okay, I didn't send you the picture.
Exactly. Then how I be able to answer that question?
Why you think the
Samuel Long.
long got what?
Are you saying you send me this? The trolley is tilted until the center of gravity is above, and I have no picture to reference. Flying. Yes, why is it?
So it's like using immersion heater to heat the water.
Uh-huh.
Then here they ask why don't we include the heat cap of the cup? Is it like negligible or is it
You can take it as negligible lah.
yes, that's ChatGPT
It
and then
depends the difference determine the time taken and after water starts boiling. Is it for this calculation or what? Or CI?
yeah.
CI, yeah. You after the water starts boiling. Okay, so the water boils at a constant temperature,
Mhm.
which is 100, which means that the cup itself would be 100 as well. So there'll be no heat transfer to the cup, assuming the cup did not lose heat to the surroundings.
Okay.
Yeah, so you don't need to consider the heat capacity of the cup.
All right. Does that
Yeah.
specifically drop thermal equilibrium, something like that? Or
Yeah, you can.
okay.
And if you look at heat capacity, it's Q equals to C delta theta. If you are at 100 all the time and you're not going anywhere else, the delta theta will be 0, which means that your Q is 0. Yeah.
Okay, yeah. See,
Yes, Samuel Long.
here's the reference image.
That's a trolley.
Yeah.
The trolley is tilted until it's vertically above the pivot. Explain why this reduces the force to balance the trolley and the suitcase. Where? Center of gravity or suitcase? Oh. Does anyone want to chip in the answer?
And so I don't think
Right.
you grab the trolley in turtle.
Hmm?
Okay. They tilt the trolley back and then the gravity is against the bucket.
So the trolley is somewhat
What else? Choose that.
like this. Uh the the suitcase is something like that lah. Yeah. So why this reduces the force to balance the trolley and the suitcase? That's the question. Something about moments.
Something about moments or nothing to do with moments?
Something about moments. It's moment like this that
Moments like
test your understanding of moments.
oh, I thought you were gonna say moments like these that test your sanity, that test your sanity and patience.
My sanity and patience were gone when you didn't send me the picture of the question and simply send me the question yourself.
Yeah. It is crime.
True.
Question: does the CG have a moment about the pivots?
No, I'd assume no because it's directly over the table.
Yeah. So why not?
But why it does not have a?
Yeah.
It's because it's directly over the table.
Not just that. Can you answer in terms of moments?
Moment requires force times distance. You only have a force times distance.
Why is
Huh?
why is there no distance?
No distance because you're directly over the freaking pivot.
So perpendicular distance is zero. So there's a moment. So therefore there's lesser force required to balance.
I see. Oh yeah, because anything from zero is true.
Yeah.
Okay. This whole question, I need to finalize. It took
AMI.
like 2 hours to do it.
It took you 2 hours to do this question.
I had to Google the wiki for it, and I found this like 5 minute video just to explain it.
Hush. Oh, that's a Faraday's disc.
Yeah.
Yeah.
Okay. So first of all, I looked at it. I didn't see any like current source, so I was kind of confused. And they
If
asked why not attractor. I was thinking it's either this one is like equal pulling force, or maybe it's stuck on here. But the Google said this is
it's not magnetic.
yeah, it's not magnetic.
Copper is not magnetic.
So yeah. Then this one is just Faraday's. This
Yeah.
one was where the problem started because it's a it's a wheel, like the
This will take some time to explain.
yeah.
Can you take a picture so that actually I could send something from the H2 physics lecture notes on how
Yes.
Faraday's this work. Yeah.
That is a fine question.
It's pure. Samuel, this one you okay lah? The magnet thing.
Okay. So
I forgot that steel becomes a quantum magnetization.
So how should I put it lah?
Yeah.
so I watched the video online. It was saying some right hand centrifugal whatever force thing to it. But all I got was
Yeah.
inside positive, the ring is negative, right? So then
Pushes all the electrons out lah.
yeah. So
Yeah.
then as I after that the video kept talking about how you derive the formula, and it's like, okay, I don't need this. So I was
The
looking at this
T equals to d phi minus d phi over dt.
yeah,
Then NBA over dt.
BAF.
Then A is
What is it?
pi r squared.
So roughly with right hand, right? To this part, because it's tangent, the force is going to the right.
Mhm.
The current positive to negative is going up, and the magnetic field like this. So that's kind of what I said here. It's like looking at this very instant going up here. The right hand says like this. So
The right hand, the force is going towards the right. Magnetic field is here.
yeah.
So which tells you that the current
But
cannot be the charge goes up. Oh, the current goes
yeah,
up. But there's accumulation of electrons lah. They're all the electrons that are accumulated here. So uh
positive to negative.
positive to negative and current goes up.
Okay. But then am I wrong? Right hand's removed from syllabus, right? So I have to explain with left hand and lens, right?
Yeah.
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 So then so when the
If you use left hand, the force, okay, because it's going like that, and uh the the electrons over here, all of them are actually going this way, which means that the current will be switched this way. Electrons are pushed down.
Yeah, so I mean that's where the second
Electrons will
part
then
is.
be pushed down.
So
If the electrons push down, then you get accumulation negative here, positive here. But it doesn't make sense.
is it lens like the electrons will try to like oppose being pushed down?
No, it's best to use this left hand rule. But the question is, how do we use that? North to south, electrons going that way, then means the current is going this way. Electrons will be pushed down. What does the answer say?
There's no answer key. I don't have the answer key for this.
No, then it should be the other way already, based on that. Carbon brush here. It should be from carbon brush 1 to carbon brush 2.
Oh,
Because electrons are being pushed down, you get negative here, then this one will be more positive. So the current more positive, current will flow like that. Positive to negative.
wait, hold on.
Yeah. Because down here will be more negative
Uh-huh.
based on that. Okay, so like I explained to you lah. From here to here, right, like this, right? Then the force, the wheel is turning here means electrons are moving here, which means the current is the other way. So the force will push the electrons down. So it causes accumulation of electrons over here. So this part here will become negative. Then since there's less electrons here, it become positive. So then this is taken is similar to like this.
DC, yeah. Yeah. Okay.
So this is carbon brush 1 and this is carbon brush 2 lah. So you'll flow like that lor,
Okay.
through the galvanometer this way.
All right.
Yeah.
Then, second question asks to plot current against time. Normally, if it was something like AC or DC, I would draw some kind of sine or cosine graph. But then, this is like, uh, it's telling me the time to rotate. Well, once the thing is set, it's like it's top speed. The isn't the current just gonna be a straight line? It's gonna be constant, right?
Yeah, it should be a constant lah. Yeah.
Yeah. Then just for like the starting part, then do I assume that the disk is already at its max speed, as in just a straight line like this, or do I assume that it has to like accelerate up? It just says it takes
It should be constant lah. 0.2 seconds to make one complete rotation.
mean anything, right? Because this
It
like
should be a constant.
DC.
Yeah. It should just be a flat line here. Yeah.
So not even start at 0, like origin.
No, it doesn't have to. Doesn't have to.
Okay.
Yeah.
Yeah. And then after that, I think the rest is
So interesting.
DC and whatever.
Yeah. Okay. Phew. This one you know lah. 7 long.
That one's
Do you get it now? Right hand grip rule.
yeah, it's
Look for the polarities. And then then it attracts. Because the polarity is unlike poles.
wait, what?
Right hand grip rule.
Mhm.
So I think I took a look at your diagram for 1 second. I can't remember the poles, but it should be unlike poles. Yeah, so the right side of it is soft lah.
Mhm.
Right side of the solenoid is soft. So south will attract north lah.
Yeah.
That's why the bar magnet moves towards the left lah. Unlike poles attract.
But let's say again, but you're using right, you determine where the tires will.
Yeah, you can say by right hand grid rule, the polarity of the solenoid on the right side is south. And since it's unlike poles with the magnet, the left side of the magnet, so there's an attractive force lah. Yeah. Right. What's this for question 10? What is happening?
Yeah, what is that?
You're gonna need to be more specific with your question. What is what happening?
Question A, part 1. Use figure 10.2 to determine the potential difference PD across lamp A.
Do you read that the question says current in lamp A is 15 milliampere?
What does it say then? Oh,
Above A part 1.
then what's the difference?
You said to go and find lah. Look for 15 milliampere from the graph. Then you do the dotted line thing for coordinate geometry and then just draw it down.
Looks about.
And that's the answer.
Oh, no. And maybe
Samuel Long.
yeah, might as well be.
Samuel Longitudinal.
Yeah, it's just really my favorite square. What?
Alright, let's go. This is
Yeah. Masteries. Samuel, can you try the others?
Okay.
Do.
Well, then can I go and break some?
We haven't finished all your questions, Samuel Long.
You go on. Cross that.
Raw stuff's not even working, bro.
Why?
I tried yesterday. It doesn't work.
Well, it might have been
Fixed from what my friends tell me.
when you. I don't think wrong, but what? So what time you pay is it?
Afternoon.
Yes. So it's been 24 hours. The idea of fixed. Yeah.
I don't know, man.
You can.
Oh, Yoshi really owns his name, huh? When your profile picture is Yoshi.
What?
so fat Yoshi.
Fat Yoshi.
Oh.
Wait, doesn't you have like Mario games at home? Nintendo Switch.
The Nintendo Switch. I don't know if Mario games.
Is there Mario games?
Like Super
Oh.
Smash. Don't know. Yeah, I don't think I have any Mario.
Mario Kart.
Wait, you own a Switch, so what games do you play?
Tried Pokemon Sword and Shield. Also tried the Scarlet and Violet along with Super Smash.
Is it Zelda?
I think that but I didn't try it. Mostly my brothers who use it.
Huh. Cool.
So I have questions also.
Yeah, I know. Oh, you can use Fleming's right hand rule. According to the question. Yeah, Gabby, what is this? The glider has no engine and stays in the air. Explain how convection current.
The question's in front. The question's in front. Yeah, this one.
Yeah, that's really, yeah, those swap it. finicky. Because when it says when I saw jet, right, and I saw aircraft, I was like, I did not know that like I didn't understand why it's a convection current, knowing that aircraft stay in the air because of the difference in speed on the top and bottom of the wing. So I wrote that down instead of
Well, is there something above that we can talk about? Show me a question that we can use. Shows the glider. Huh. Okay. Um, this is the kind of question that if you don't get it, if you don't get to, if you don't get the answer right, it's fine. I think it's fine.
oh, is that
No, it's not. It's that hard. It's something that you cannot get the answer in exam lah. But actually, the principle of this is based on a windmill principle. I don't know whether you have seen this before in primary school, but maybe not lah. It's basically a setup of a candle, and then you put a windmill, a toy windmill on top, above the candle, and then you observe after a while what happens. Basically, the windmill will turn, it will spin
why?
because the hot air that rises, it will continue to rise until it reaches the windmill, and then it will cause the windmill to spin. So there's actually an upward force exerted due to the rising air. And this hot air rising part is the convection current that they're talking about over here. Yeah. But you couldn't have seen that in the exam, you see. I have to be practical and think about from your position how you can actually answer the question.
Mhm.
Which is why I say if you can't get this question right, it's fine. Because there are many, many opportunities for you to score.
Mhm.
Yeah. But let's
So,
say you do,
so how do
let's
we
say
put it in words?
um the hot air, due to convection current, the hot air rises and exerts a force on the glider,
Hot air rises and cools.
causing the glider to stay in the air lah. Yeah.
But then what's stopping the glider from gravity?
Like what I mentioned, is the hot air that exerts an upward force
That's enough to counter the gravity.
for a while lah, because the glider itself has huge wingspan,
Mm-hmm.
a lot of surface area in contact with the hot air. So that's enough for it to stay afloat. Now after a while, depending on how much convection current you have, maybe you will start to fall lah. Yeah. But then again, you got the picture shows a plane towing it, right? The plane probably helps to keep it upright longer. Yeah.
Can you write it down? Sorry.
Okay. Yeah, something like that.
It's for the hot air, right?
Mhm.
Say anything about it. I see that it expands when comes like uh less dense 100 euros.
Uh, you can say that, but I feel that for this component, it may not be needed because they're not asking about how the air gets heated up or how a room gets heated up, you see. So when you are asked like the kitchen question about from Samuel about how the kitchen is heated up, then you mention about air expanding and all those things, creating a convection current. But in this case, they already mentioned the word convection current inside. So since there is a convection current, there's no need to explain convection current. And just going to say hot air due to convection current.
I bet it's like it's the opposite. Like the environment is hot, you put like cool sauce. Then do anything to the fan or what?
The fan?
Yeah.
What fan? There's a fan?
Is there not a fan?
Oh, you mean this windmill? Yeah, that's Drew. What's your question?
I bet is it the environment is hot and the guy puts a cool sauce. So
This is cold source.
yeah.
Then nothing will happen. There's no convection. But hot.
Yeah.
Everywhere is hot.
Yeah, everywhere is hot.
Uh, maybe. So the air will rush down, will sink and push the fan. Maybe that's possible. Yeah. Yeah.
It's gonna be a practical test in the future.
Oh, it's a fun test. Like you can just get it. You can buy a toy windmill and then light a candle underneath.
So to make it faster, you just increase the heater. Or
Yeah. Well, actually, the what you see here is how power stations work. Because you have your water, and then you have your heat source, and then at the top you have your turbine.
That's what I thought. You use coal to make steam, then the steam turns
Yeah, it's the same idea.
Oh, I thought the steam, right? I thought it's like the same, similar in the steam engine, but the steam is pressure, right? It's
Yeah,
to push the thing, not just general heat.
yeah, it's the same idea. All of that actually comes from a simple toy.
Yes. So, basically, you're telling me that theoretically, I can cause my ceiling fan to spin just by having a big enough fire underneath it.
Well, it depends how heavy your ceiling fan is, but yeah, if you got like 100 candles underneath,
In Singapore's heat, I think that will help a lot.
and what? I, I don't think that helps when there's already a lot of heat and you're burning something in the room. Yeah, don't try that at home though.
Yeah, that's it. I was going to go to White House.
Simon is always insane.
please stop doing.
Yeah, because Samuel Long got 101 questions to ask. So we can't have break today.
Like really funny.
Um, you will have to check for there's no total internal reflection. Then just draw a normal reflection.
So like any angle, any
Yeah, they draw a lightweight bending away. then just indicate the angle. Calculate incident angle at P, Q. Oh, you're not given the prism. To find this actual angle here, you have to find this angle, then you can use triangle to calculate geometry lah. But you don't have, so you just have to estimate. Gabby, you got other questions, right? Or is that it? Is this one yours, Gabby?
Oh no, this one is because Samuel forgot to send just now the front part of the question.
Oh, okay.
Yeah, the question's on the next page.
The wind's speed.
Hmm.
Oh, you mean Samuel forgot to send the entire question and only asked me about that particular question?
Yeah, that one.
Mm.
That way you didn't go.
Decrease by a factor of 1,000.
Wait, let me flip to the thing first so I completely understand you. Really?
What is 20 square minus 2 square? Is it 1,000? I don't know. $396 K three. Then the rest is times half M. What is half M? A per second. 130,000. I think you need to calculate out lah. Gabby,
What?
getting energy of air. So this is 20, right?
Yeah.
You can actually calculate this out, ma, from 20 to 2. So you did one for 20,
Mm-hmm.
and then you do another one for 2 lah.
I know. Actually, I know how to do this question. I'm just helping Samuel.
Okay, so I'm going to calculate it out.
What is wait, what's the
If you found A part 2,
A part 2? Yes.
if you find it out,
Mm-hmm.
that's for 20 meters per second.
Uh-huh.
Then calculate out for 2 meters per second. Then minus all, then you can see whether it decreased by a factor of 1,000.
And V squared are basically
Yeah.
times and M is what? 130,000 times 2 squared. 260 versus 2.6 times 10 power 7. So 2.6 times 10 power 7 whole not over my answer. That's 100. That's 100, not 1,000.
Do you check there could be something wrong with your working lah.
Unless I see earlier.
Huh.
Historically, that has happened before.
What?
Okay, so I said half life is the amount of time in years for a radioactive sample to decay to half its initial life. This one says it's half the number of nuclei to decay. Same thing, right?
Yeah, same thing. It's fine.
Okay, good.
Gabby, did you say anything else? You didn't say anything, right, Gabby? Choo, 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 choo. Okay, I did this.
This is not my factor of 10 insurance. Let me see my working day.
Because your M must be correct. It's not the same M.
Huh?
It wouldn't be the same M.
Why?
The speed drop, ma.
Uh-huh.
The first part of the question you calculate using the speed, ma. So it wouldn't be the same M.
Uh-huh.
So you must recalculate the M again, get the new KE out again. Then you can get 1000. What's this question, Samuel? What do you want to ask about this?
Literally half like half like
The frequency of the varying current is equal to the frequency of the sound wave.
on the free.
Just look at the graph lah. Find one period.
Okay, one period and 2 minutes again.
Yeah, then 1/2 millisecond. Convert to seconds.
So 2 times 10 minus 3.
Yeah.
So frequency is 1 over period. Well, but period is 1, like 1 over 2 times 10 minus 3
Mm.
is 500. So my frequency is 500 hertz.
Hmm.
So frequency is 1 over period.
Yep.
Hence one wavelength. Sound will be 300 equals the air frequency 500 x equals 0.64. I think I got scared by next one.
Intimidated by a graph.
Yeah.
One can say you had a graph time.
Not cool, bro. You-
Damn it, no flip for trees.
Wait, what are you saying?
Wait, no peace, man.
It's the kind of joke I have thrown out later like every other day.
Why every other day?
I come here like I used to come here 3 days a week, bro. They were the worst on Wednesdays, so the math class made me the part of most jokes.
Yeah, that's me, but
No, I mean my classmate is the part of this guy's Oscar's jokes.
Your classmates.
the
The
Bible
Bible jokes. Like the subject of his jokes.
No.
No man. Now when you keep calling Nicole a 90-year-old grandmother.
It's a compliment.
shit, you. Yeah,
You're the one who kept continuing the joke.
we are Chinese.
Hey, what happened to the wood that I like about it?
Is there? You want to wear it?
No.
We're all waiting for you to wear the wig.
Yeah.
Okay, let's see what else you got. Samuel Long, any other things I didn't go through? One is good that you have questions to ask,
Why did I ask too many?
but the Well, the thing is, you could drop the questions first, and that would help. Oh my God, why are you asking me this question at this point in time? What is W equals to QV?
Yeah.
Wait, so power does equal to all equals to
Charge times voltage.
Huh? W equals to QV.
Yeah.
Work done equals to, yeah,
Charge the bulb.
V equals to W over Q lah, actually. That's the original formula.
V equals W over Q.
Yeah.
V EMF or V PD?
Could be PD, could be EMF. They use it,
It's the same anyway.
yeah, the same formula applies.
So power equals work done over charge.
There's no power.
Sorry.
V equals to W over Q.
With W being
V is either the PD or the EMF. W is the work done.
and then
There's no power here.
oh
You may be confused with watts, which is the unit for power, but this is
just a generic W.
the symbol for work done.
Hmm.
Yeah. This is a very simple question, actually. You should have no issue doing this. Okay, so make sure you learn how to do it. The energy in this case is it will be QV. So just take 24 coulombs times 40,000. But you have to convert to voltage lah. So you have to times another 1,000. Because it's 40,000 kilovolts.
So for this question, right? Why they ask me?
What are you asking?
Yeah.
How sound travels on? How sound travels?
It's a medium show.
What happens at the speaker?
Huh?
When you touch the speaker,
With vibration.
start with that.
Okay.
Yeah.
So like the loudspeaker vibrates
Uh-huh. Yeah.
and the vibration makes up.
Let's ask Samuel Long how to answer that.
Oh, what's the question?
How does sound travel from the loudspeaker across the air?
Loudspeaker causes particles to vibrate, and the particles they cause the air particles to vibrate. This vibration travels from the loudspeaker to the person's ear. The person's ear converts the vibration of particles into electrical current, which is then recognized as sound.
Right?
Okay, you have to mention about vibration. You have to mention about surrounding air molecules
So I see surrounding air molecules come in contact.
come in contact, vibrate as well. Then and collides with other air molecules. Then this creates a series of rarefaction and compression.
Oh yeah, I forgot to talk about series of compression.
Transferring the energy from A, usually the source, to point B, destination. So in this case, the source is the loudspeaker lah.
Let me change the ears.
Yeah.
So transferring the energy from
Yeah. Samuel Long, there are two formulas to remember. W equals QV is one of them. The other one is Q equals IT.
W equals Q equals IT and V equals W.
Yeah.
I thought it's police that's the police department or the EMS or something.
I don't know.
Okay, so then you were saying it's QIT transpose QIT whatever and then the other one is V equals W. W work done over time. Yeah, overcharge.
Yeah. So usually I remember like this, like Q equals IT, right? It sounds like
Kit
Kit Kat. Then the other one is QV facial wash.
Making go.
It's a brand at Watson. You,
Oh,
um,
possible.
But if you got other ways to remember, sure.
I remember like QIT is like Kit Kat what else?
Yeah.
No one should bring
So remember KitKat and QV facial wash. That's how we can help you.
QV.
QV facial wash.
Yeah, QV visuals. So W equals to V.
Yeah. Two important formula to remember. Because this kind of question, right, they will come out. It could be either MCQ or open-ended. And very easy to score on.
Mm-hmm.
My advice for you is write down the formula first before doing it.
You were saying?
Well, is the EMS, the emergency medical services, sound travel tablet.
Yeah. Okay?
Sorry, you were saying something. I was mildly distracted by the ambulance.
Remember these two things, which is the KitKat and QV facial wash.
Okay.
Because they could be worth between 2 to 4 marks or
Wow.
even more. Okay. No other things, yeah. I think I covered all.
Hello.
Mm.
Okay, so I thought I knew how to do this, but answer key says, yeah, a current flowing into this produces a magnetic field. So it's probably the right hand or something.
Yeah.
That interacts with the magnetic field of the magnet. And then this interaction is either repulsion or attraction constitutes the spin.
Mm-hmm.
So I can just like explain what is
What? Which part?
like the
F.
thing. How would I even know it was
The
clockwise?
current flow. Explain why the disc rotates on its own.
Yeah. I thought it's just left hand, then the thing will just move on. This one says it's like repulsion or attraction, I don't know.
Okay. Because the disc now has a current,
Uh-huh.
and this is actually EM. So this is EMI, and
Uh-huh.
this is EM.
Okay.
So when you have a current flowing, uh, here lah, which is current will be down, magnetic field like this, current down. So where's the force? This way,
Yeah.
So it causes this to turn.
That's what I said. But then the answer key is saying it'll produce a magnetic field that interacts with the magnetic field of the magnet.
Okay, so your Fleming's left-hand rule, how you derive all this, right, is due to interactions of magnetic field.
Ah.
So this is the concept, the logic. Whereas this is the outcome of the logic.
Okay.
Yeah. So the force that you determine here in this direction is because of interactions of the magnetic field.
So right.
Um, exam will probably look for this answer more than this answer. This answer is used for explain why it spins clockwise, for example.
Okay.
Then you use Fleming's left-hand rule to explain why it spins clockwise.
Alright.
But explaining why it spins is interaction of the magnetic field.
So do I need to know how it interacts to make left hand rule, or is it just say it interacts?
Let's say it interacts, depending on how many marks are there, it's a 2 mark, so you don't have to talk so much. But let's say they ask you to draw diagrams and all those things, right? Then you have to draw lah. Have you seen that before?
I don't think so. No, not really. Maybe I best like draw the line of the magnetic field, but not really a
So fair. This one.
So
This is what they call by interaction.
I thought this was removed from syllabus.
Remove.
Maybe wait. So I remember my previous tuition teacher got show, but then I also remember like all of this stuff, especially the like Does opposite pole attract, something like that. All those were taken out of syllabus.
Opposite poles attracts.
Means opposite repel. Yeah. But even then, that one was removed from syllabus.
The
So
opposite pole attracts repel. You mean unlike poles attract, like poles repel?
like I have two wires carrying current in maybe this direction, either direction. So they like attract repel. That one was removed.
Yeah. But this one still stay. This one is the basic of EM for motor, how a motor works.
Okay.
It still stays. Okay, guys, do you remember your Fleming's left-hand rule?
Yes.
Yep.
Yeah, so the whole principle, like let's say you have a current that is going into the page, into the screen, and then you have north to south. Yeah, north is this one is going towards the right. So if you use the Fleming's left-hand rule, right, where's the force? Where's the thumb pointing? It'll be downwards lah. Okay. Now what you have here is actually the outcome. Left-hand rule, right, is the outcome. The question is outcome of what? So what's happening actually is because the wire itself has a magnetic field. And this magnetic field interacts with the magnetic field of the poles. Now, because of the interaction, you have something like this that exists. Now, this is not difficult. The principle is very simple. If you look at the top part here, the lines are together with the north-south lines. Means they're all going towards the right. So if they're all going towards the right, right, they will merge and become stronger. So you get all the lines very close to each other because they are merging. Now the ones at the bottom of the wire, over here, it'll be going towards the left instead, which will oppose the ones over here. The north-south magnetic field lines are still going towards the right. So if one goes left, the other one goes right, they will then conflict with each other. So you get a lot of lines that are very far apart. Now, in the process, you have weaker field lines here and stronger field lines over there. The difference between the weak and the strong creates a force. The force is in the direction from the stronger one to the weaker ones, and that's why you have left-hand rule. Left-hand rule, the one that you use, right? The thumb straight away points down is because it is pointing from it is a direction from the weaker to the from the stronger to the weaker magnetic fields. So that is what it means by interactions of magnetic field. Yeah. Now, why am I saying this? If the question asks, explain why this wire experiences a downward force. No, explain why this wire experiences a force. Then you can just simply say it's due to interactions between the magnetic field lines. If the question say explain why the force is downwards, then you can use left-hand rule.
So how is it like based on that? Left-hand rule.
Then you indicate the direction of the magnetic field and the direction of the current, and then therefore the force is downwards. Now, if you want to be safe, you can include both answers.
Like what?
Due to interactions of the magnetic field lines, the magnetic fields of the wire and the magnets, there is a force produced. This force can be, the direction of this force can be determined by Fleming's left-hand rule. Then talk about the directions. Yeah? And we are done.
So sorry, I have a last question because like you kind of gave me that paper before. And so like I have a question from that paper that you just gave me. Yeah.
Okay.
So I send it a group, I think.
Oh, okay.
Yeah.
Do 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 do. Boat A shown.
Yeah,
The sciences group.
what is the last one?
Last three. 100. Hey, what do you think about the English, you guys?
English?
Yeah.
SW was pretty okay. I thought it was the compo I that's kind of hard for me.
Which version do you?
Just five, because like I don't know how to argue for
Right, good.
parents and grandparents have forgotten how to be old. That one.
About the ink thing, so
But yeah, paper two was really good. Could be worse.
It was easier compared to like last year.
Yeah.
Okay, so the vibrator is actually over here, which means that the energy will be traveling here lah. It's important to take note about that. This is direction of flow of the energy. What's your question, Gabby? How to draw this
Yeah, the displacement time graph.
for boat A lah. Okay.
Mhm.
Now, to understand how to draw the displacement time graph, you have to draw the wave in the next instant, which should be something like that. So from here, you can determine that boat A is going down, lah. So all you need to do is start from the highest point, the crest. Did it give you the amplitude? No. So all you need to do is start from here, then go down, and just draw lah. Indicate relevant values on both axes. I think you just need to include the period, which will be 0.5 seconds. Are you able to find anything else?
No.
That's it. Let's see. How come got 1 and -1? It's a displacement. That's strange.
Why is it 0.05? Oh, it's because it shows 2 cm. What do you think?
Yeah.
Oh, okay, yeah. You can get the amplitude from there, 2 cm. So this is 2 cm. So therefore this is 1 cm and -1.
But what the timing 0.05? The answer is
1 divided by 2 is actually 0.5.
yeah, but
That is 1 period.
0.05.
It seems like a mistake. Yeah, it seems like a mistake. 1 period will be 0.5. 5.8. Yeah, 1 period is likely 0.5 lah. Can't be 0.05. So that's a mistake. Gabby, does that answer your question?
Yeah, thanks.
Okay, so make sure to start at the right point. This is crucial because A was up here. If you draw C, for example, then it will be something like that. This will be for C. Okay? If you draw B, for example, then B will be like that.
Okay.
Yeah. Okay. When will I see you again, Gabby?
Um, I'm not sure yet.
I'll see you Sunday, right? Okay, I just post in the group lah, then you all go and decide and let me know.
Okay. Okay, yeah, okay.
Okay. Bye-bye.
I think I
Bye.
saved battery. Thursday.
Oh, Thursday, yeah.